Welcome to the 16th session of Ergonomics for Beginners Industrial Design Perspective. Now, the current module is the fourth module, that is posture and movement. Within this posture and movement, today's session is the class number 16, posture and its job relation. Now, with this just to recall the last classes, the gist of last class is that for if any work condition we adopt some posture that is required by the task, and for that we adopt some different awkward postures for different purposes. Now, it can be said that like fire triangle, heat, oxygen and fuel, if any one element or in combination, if the intensity is reduced, then the effect also reduces. Like that, triangle of ergonomics risk, that the elements or components may be posture, force and frequency. So, similar in principle to the fire triangle, if any one ergonomics risk factors is out, it would minimize risk. Now, we are discussing this today's topic based on the postural requirement and how we can improve the posture and the relation between posture and work output. Now, in this neutral position of body versus awkward posture adopted for specific task, activity or task should scope a coordinated balance among the body parts or body as a whole, as close as possible to natural position, so that the ergonomic risk association with the task would be minimized. In continuation to the gist of last classes, it can be said that if any movement or force be applied either using a part or the whole article, the direction of force application should go with the configuration of the human body, that is, it should synchronize with the human natural movement axis, so that the maximum mechanical advantage could be achieved. Now, with this in continuation, the today's topic class number 16 is that posture and its job relation. Now, the risk factors for any activity, it has shares of tools and equipments and materials, their design, materials availability and its quality, workstation layout is all the work equipment and body supportive devices to maintain a certain comfortable posture, and the space in between, and the links of different work components and human operator or human users, that is the workstation layout. Awkward postures required to be adopted due to certain problems. Forceful exertion, if someone has to apply force in a specific posture, then its intensity, these also add to the ergonomic risk factors. Then repetitive motion, if a certain task requires to be performed with repetition, so to do that task, whatever energy we spend, we are not getting enough time to pay back or to complete the debt recovery. So, the repetitiveness or repetitive motion, it also adds to the risk. Then duration, how long that task is performed in that condition, and the other physical environment, like if the lighting condition is not good or if glare is there, then to do a certain task we require more energy, or we can say that it requires some extra effort, and sometimes it also requires postural attention. So, all the things of the physical environment, like another thing, if suppose in an work area, suppose some heat generating object is there, and but we have to operate on that. So, to avoid that heat, body may take an awkward posture, so that to avoid that heat, etc. So, all these these elements or these factors, they contribute to the ergonomic risks of a work. Now, here we would be discussing mostly on the awkward posture and others relation to that. Now, again coming to this same thing, that fire triangle and ergonomics risk triangles. The hierarchy of controls is comprised of three specific areas. The first we can say that engineering controls, that is designing a machine or work tool. Second area is that administrative controls or a job, means a safety manager must consider administrative controls, emphasize minimizing the machine operator's exposure to risk. Rather, administrative control tactics may include like designing a job rotation schedule, decreasing the frequency of certain movements by adding more operators to a particular job, or changing job processes to lessen the amount of risk. And number third is that personal protective equipment, that is guarding self, etc. So, these the controls can be used to minimize the ergonomic risk factors. Now, ergonomics risk not only in the production area or in office area, but if we see in the other activity areas, such as in this figure we can, it is seen that the person himself is putting effort along with the bullocks to pull the cart with the load loaded cart. So, in this case the position we can see here, it is not the right position to give a pull force, or we can say that he is controlling these two bullocks movement with extended arms. So, this risk is there, his body pains and etcetera are all will be there. Now, another area we can say that the person here in a cycle is carrying coal bags. It is so loaded that he cannot sit on this chair, on this cycle. At the same time, to make it move, the posture he is adapting is not a very natural walking posture or carrying posture. So, he is also adding a force to make this cycle stand as well as move. Now, when the person requires some rest or the cycle needs to be put on a stand, then the normal stand here it is not effective. So, he is carrying a bamboo piece here, and this bamboo piece he is using as a side stand for this. So, now in this, if we consider this as an occupation, as a problem area, then this posture how we can improve. So, accordingly the design of a cycle is necessary, or a specific accessories can be added to a normal cycle, or a different carrying vehicle to be designed to ease this postural problem. We need to think of it. Another example it can be said that static load. Now, natural posture, when we see, if we stand, we can say that it is close to natural posture. But if there is a load on head, whether that natural posture remains as natural posture or it starts stress on body. So, and at that same time, when these girls they dig sand from the sand bed, sand pit, so there are a complexity of a various postural movements are there, and while carrying she has to walk here over the soft sand that gives a special resistance. So, to overcome that resistance, some additional load on body comes. So, for that what type of design suggestions can one can develop, that is a good scope of work is there. Now, the height of work of a platform and the total task as shown in this figure, whether it matches with the body configuration or the requirement need to be considered. So, the posture in this case, it is not the simple bending, it is an angular bending is being taken because of hurriedness and some other privacy purpose or whatever. So, with this it can be said that the awkward adapted posture and inefficient work output has a parallel relationship. Second, people have different capabilities and job or task demand also varies. Third is that towards making compatible interface between these aspects, attempts are being made and ergonomics looks into it as fitting the task to the human, not like the fitting a man to a job. In many cases, it is seen or noticed that while procuring some furniture or some work equipment, machines, etc., we first buy those things, we procure, then we put in a place, we say we call it a workplace, then we ask a person to work in that. So, that mismatch comes there. So, instead that it would be better if we can find out what would be the necessity, the likely to be users or operators or workers capabilities, and accordingly if we procure the equipment and build the workplace environment, it would be good. Now, different postural adaptation for different purposes, that is not anticipated. Like in this, the furniture provided is here is for normal sitting and resting, but here we can say that this lady is talking or using a mobile phone, and for that she is taking a this height of this arm, this backrest as a elbow rest, and so to use that her total body posture being taken in a different way. So, it is neither standing nor sleeping, but she is getting a support here. So, this furniture is not made for this type of postures, but she is adapting it. So, some physical problem may come here, and also we can see that different other sitting areas here and how people are using. Means when we provide a facility, how those facilities are being used, and for that what type of postures we are adapting, and for and as a result what are the ergonomics risks we are facing, that we need to consider, and accordingly those facilities to be reviewed. Another very interesting case is that here the workstation, the seat, desk and the computer monitor and keyboard, mouse, etc. This workstation is meant for an adult person with his body posture, with his body dimension and its others. But if other users like the small girl, they also use this facility, then her body structure does not fit with this, but to perform the same task, she has some additional postural stress is coming on this body. So, then what would be the additional support system one can think of that needs to be considered. So, with this we can say that people have different muscle strengths and cognitive abilities which is dependent on age, body build, gender, health, individual training and other context specific relevant factors. Every human body follows the same biomechanical characteristics. Ranges are also within a certain limits. Understanding of these human aspects led us to bring out principles of good work, principles and methods and workplace design which enable the exertion of muscular strength with most efficiency and least effort. Now, the occupational stress. Tea is a very common thing in our daily life, but if we see in a tea garden how the tea leaf pluckers they pluck the tea leaves from a tea garden, is that they have a special tea bush with a special dimension. Sometimes it goes more than 1.5 meter in length and breadth, that table. So, while standing on a corner and to reach the end of this tea table, so she has to take a extended arm position, but the load here, the plucked leaf storage, that basket is tied or hanged with a string or strap over her head. So, the total load is here. So, with that load she is taking this posture, and also in this posture she has to retain this posture for some time to pluck a certain area leaves. So, here the repetitiveness and duration of this postural hold and the load all are adding to the occupational stress. Now, if we want to reduce or improve this posture, then what can be done? Studies are necessary in this. Now, certain tasks that is not a fixed type work, like for this in a car repairing shop, these people they adopt various postures, standing, sitting, squatting, going under this vehicle. So, all these things. Now, a question comes to adopt this posture here and to do certain task, whether we can give a sitting stool. If we provide a sitting stool here, then the next moment he has to stand up, then it is not necessary. Or if he goes inside, then we can have a special trolley we can develop. Then this trolley would be a separate thing. This type of stool design may be a separate tool. So, like that, as per context we can develop some design. Whereas, in the earlier case here the task is almost same, continued or a longer duration. In that case the carrying mode can be designed to plug easily, that some specific device can be developed, so that she does not need to stretch her body. So, in this case some specific design can be developed, so that many people can use that. Whereas, in this case for specific task specific type of design is necessary. So, occupational stress, it can be said that the emotional state or mood which results from a discrepancy between the level of demand and the person's ability to cope defines occupational stress. It is thus a subjective phenomenon and exists in people's recognition of their inability to cope with the demands of the work situation. It is defined by Kromer and Grandin in their book Fitting the Task to the Human, Taylor and Francis in 1999. Now, occupational stress, the basic assumption is that the degree of fit between the characteristics of a person and the work environment can determine the well-being and performance of the pupil. Now, work layout. With this work layout, we can say that if this is an weaving related workplace, where different components of weaving and related work is being performed at various postures, like squatting, sitting, and then with a loom, the frame, they are sitting like this. So, task involving precision and manual operation requiring multiple posture adaptation. Another thing, while taking this posture, now it can say that she has to concentrate on this area, but sitting somewhere here. So, it can be said that the sitting, if this is the main axis, so the deviation is there and she has to operate here. So many bends at different angles are there. So, with that, and she also needs some kind of rest pause and then some structural support. So, if without changing the main loom frame, if the special seating arrangement can be done, then it may have a good effect on the body as well as the performance, the productivity. Like if we have a special backrest kind of thing, it is away from the main platform, so that when she needs to take rest, she can take a backrest. When she needs to bend forward for activity, here we may have a bent here, so that to operate on this pedal would be easier. So, like this some steps can be taken to improve the working posture. The static load, here the machine is been developed to clean the weeds. This is a moving blade he has to carry, and here some switches are there that can be operated to control this movement. But he has, and this is a machine kind of thing. Now, he has to hold this with a open arm always, and so though he is moving and the main operation, the cutting operation is done by the machine part, but to operate this machine, this person has to hold it, and so a static muscle load is there. So, now if we can make some provision of this here holding, so that bringing closer and wider and movement as per his own will, it would be better. Now, how it can be incorporated in this task, that is a good design thoughts is necessary. So, work layout, it can be said that a static load on muscles led to painful fatigue that are wasteful and exhausting. For this reason, a major objective in the design and layout of jobs, workplaces, machines, instruments and tools should be to minimize or abolish altogether the need to grasp and holding things. Unavoidable static effort should be reduced to not more than 15% of the maximum and 10% for long lasting loads. Dynamic effort of a repetitive nature should not exceed 30% of the maximum, although it may rise to 50% as long as the effort is not prolonged for more than 5 minutes, as reported by Van Willy in 1970. Now, with this work posture, various work postures are being adopted here. With this, for a good work practice, there are 7 common guidelines as per available literature. The 7 guidelines of good work practice, it says that number 1, avoid any kind of bent or unnatural posture. Bending the trunk or the head sideways is more harmful than bending forwards. So, with these guidelines, the workplace design should be done. Number 2, avoid keeping an arm outstretched either forwards or sideways. Such postures not only lead to rapid fatigue, but also markedly reduced the precision and general level of skill of operations using the hands and arms. Number 3, work sitting down as much as possible. Workplaces where the operator can choose to either stand or sit are recommended. Number 4, arm movements should be either in opposition to each other or otherwise symmetrical. This type of movement one can do, this movement is possible, but one hand forward and one hinder, it is not possible, it is not easier. So, some control movement that requires such kind of movement is not advisable. Moving one arm by itself steps up static loads on the trunk muscles. Furthermore, symmetrical movements of the arms facilitate nervous control of the operation. Number 5, guidelines. The working area should be so that it is at the best distance from the eyes of the operator. It is seen that from eye, minimum distance around 13 to 15 centimeter, before that we cannot make any focus, good focus. Till 30 to 45 centimeter we can see the best, and around 65 to 75 centimeter from eye we can see it with clear minute visions. So, accordingly hand grips also should be there, so that hand control and vision will go together. Now, the sixth guidelines we can say that hand grips, operating levers, tools and materials should be arranged in such a way that the most frequent movements are carried out with the elbows bent and near to the body. The best position for both strength and skill in the hands is to have them 25 to 50 centimeters from the eyes. This is the range, comfortable range, with the elbows lowered and bent at right angles. Now, the seventh guideline for good work practice, we can say that manipulation can be made easier by using supports under the elbows, forearms or hands. With a suspended arm, any kind of work activity, it adds with the static load on body. So, if we have a support either on the elbow or wherever we are working with this palm rest, it would be better. These supports should be padded with felt or some other soft warm material and should be adjustable to suit people of different sizes. So, this literature are also taken from Cromer and Grandjean, as they have done at 1999, from Fitting the Task of to the Man, 5th edition, Taylor and Francis. So, here, so whatever these guidelines are provided, this is taken from this. Now, the carrying. Now, simply in this figure it is said that to lift and carry, the body is taken a special shape and arm is at a bending area. So, for different body size, gender variation and the strength it differ. So, what would be the appropriate handle size? Like in this box, this carrying bucket, there are 2 handles. So, to be carried by both persons, but actually the load it requires for 3 persons to carry. then the purpose, need and the intended mode of carrying, if it does not match, then what type of approach a solution to be given, that it requires a context specific search. Now, workplace hazards, working on floor, and also in this figure it is seen that while drinking water, the person has to bend, here also he has to bend to see a notice board somewhere. So, this is the posture he has to take. So, this will be appropriate posture, but to see the lowermost position he has to bend, and for children it is little difficult to see it. So, the purpose remains same, that is a reach, eye and face. So, the postural strain is there. Now, postural strain depends on various postures adapted, the force required, strength, tolerance, load tolerance, joint movement and their ranges, and repetitiveness. So, all these they are the constituents for postural strain. Now, biomechanics and task oriented posture relevance. It is said that body part movement must follow normal body axis. As for example, pedals which travel in an arc, like this person, when he is pressing it, our foot movement is like this way, foot movement, but if it requires a different type of approach, then he has to extend the leg. So, it does not match with the normal body axis movement like this way. So, pedals which travel in an arc different from that of the operating foot can cause an unbalanced and tiring movement. We must need to consider these points. With that, this is a the waste cleaning system, where to the same type of benefit are getting from this operation, that is that follow the normal body axis movement. With this normal body axis movement, that pressing this button here, lever here, the box is tilted and can be cleaned. Now, if we see the muscular effort and the posture, from literature the study, it says that continuous stress on certain muscles in the body as a result of a prolonged posture or repetitive movement leads to localized muscle fatigue, a state of muscle discomfort and reduced muscle performance. Like here you can say that this is that duration in minute from 0.1 to 1000, and here is the muscular percentage from 0 to 100. The graph says like this, means if the muscular effort is more, then the duration should be less. As a result, the posture or movement cannot be maintained continuously. If the muscular effort is more and duration is also more, the greater the muscular effort exerted force as a percentage of the maximum force, the shorter the time it can be maintained. Now, with this you can say that avoid bending forward or backward. A twisted trunk strains the back. Sudden movements and forces produce peak stresses. Alternate postures as well as movements, if as much as possible. Limit the duration of any continuous muscular effort. In continuation, it can be said that from the literature, the recovery curves for muscles which have been exhausted, that is curve number 1. Suppose this is the recovery percentage from 0 to 100 and this is from 0 to 30 means the rest time. It says that if the rest time is more, then recovery is also better. So, recovery curves for muscles which have been exhausted is called 1 or partially exhausted called 2 to 4 after continuous muscle effort in this curve. So, from this it can be said that prevent muscular exhaustion in any workstation or if any awkward posture has to be adapted. So, how to improve it? An exhausted muscle needs to rest for 30 minutes to achieve a 90% recovery. Muscles in a half exhausted state will recover to the same degree after 15 minutes. Complete recovery can take many hours. Now, what is the gist of this? Most people can maintain a maximum muscular effort for no more than a few seconds and a 50% muscular effort for no more than approximately 2 minutes, as this cause muscular exertion. More frequent short breaks are better than a single longer one. Now, when we see this figure here, the posture, now the task she is performing here, the presence of this, it gives a problem. So, instead that if we can have a pose, it is like this. So, she can come closer and can have done this thing, or this may be placed somewhere else. So, usability, the cognitive and physical hindrance, the common body movement or position and design features, component location and identity to be maintained. Now, we have discussed the ergonomics risk factors and triangle, that force, duration and posture. Now, here the working posture triangle. The working posture triangle, it depends on working posture on task requirement, workspace design and personal factors. Means a person's working posture is a result of the workplace and personal characteristics, as for example, body size and shape and eyesight, etc. Consideration of all three components is necessary in analysis of posture and workspace design. Now, the factors influencing working posture. If we see this table here, the factors and examples, there are three factors specifically you can say. The number one factor is that user characteristic, it depends on, or we can say that age and sex, body build and anthropometry, body weight, somatotype and obesity, fitness, joint mobility, that is range of movement, existing musculoskeletal problems if it is there, eyesight, right handed and left handedness. If it is right handedness, obviously the flow will be on that side. If the left handedness, accordingly the body posture will be there. And then clothing or body wear, it also affects this. Now, the second we can say that task requirements, that is visual requirements for performing task, manual requirements, that is positional forces, cycle times, that is duration of a task, rest pauses, paced or unpaced task, means continuous task or intermittent task and rest, like that. Number 3 is that workspace design. For that, the examples will be work surface, that is horizontal, vertical, slant, concave or convex or in combination. Workspace dimensions, that is seat or stand or others, other postures, leg room, head room, head space, free space, foot room, etc., whether it are there. Then privacy is also a big factor. Based on this privacy, some body posture takes place. Environmental factors like heat, humidity, ventilation, illumination and vibration, etc. If there is a vibration, then body also may change, or stress will also be there. Now, with this we are trying to give one design solution or a trial what we made, that while lacing the shoe, in this case we need to lift our leg and we need to lace something here. So, for that one need to bend, and that bending is a problem, specifically for older age or when you have a obese or maybe big stomach, big abdomen. So, for that the study, after doing the study, it is said that normally if the foot is like this way, then lacing here of a shoe, it gives you some problem. So, some kind of velcro is attached. Velcro may be fit somewhere here or reverse way, but it is a direct horizontal. So, more bending is necessary, but if we can have little in front, maybe around 30 degree away, 30 to 40 degree away, then the movement is then the bending will be reduced. So, based on this philosophy, some activity is done, some trials. Here it is shown that 4 types of putting operation, and while opening the shoe here or placing the shoe on a shoe rack, what type of movement it takes. Based on this, the trials, the strapping trials were made, angle of strap, then some trials were made to develop what would be the appropriate strap angle, like to determine a comfortable range and position for the velcro. Newspaper strips were used for this test. A piece of paper was then adjusted as a strap, and then the position of the base of the foot was extrapolated towards the portion of the sole above the sole. And finally, this type of a shoe is developed, so that if it is necessary to wear it as a chappal type of wear, then we may reverse velcro. So, it will remain open, otherwise it may come and it can strap somewhere here. So, the shoe says that like this, so this angular is provided here, this angle is provided here. So, this is a with the posture keeping in mind, a product is developed, it is a idea is developed. Now, its final design solution is yet to be carried out. So, advantage of this chappal is that it can be used as a chappal too. Simply fold the strap to the same side of the shoe as shown alongside this to make the shoe a chappal, like this. This does not interfere with the other parts of the shoe. So, these are the total portion is shown here, but instead of direct vertical here, it is just angularly it is placed like that. So, with this we are concluding today's session, that is that posture and the job relation and some design of a product possibilities. So, next class will be the class number 17, that is posture and the body supportive devices, that is maybe sitting, standing support or a squat kind of sleeping support, or while walking and etc., that stick type of support, or in a motion area if we need to hold something to keep our body in a fixed position. So, that type of body supportive devices we will discuss in next class.